Hey guys, Jerome JT62 back with another video. I know it's been a while since I've posted anything, and I've been wanting to go over this spool rewinder since I built it. There's one other thing that I'd like to do to it. We'll go over that. But we all know about different size spools. Many times I order from different companies and they're different size. I like this size. And then you have the fatter one, but I like that. So I got the opportunity to get down to a little bit of filament. I'm not going to redo a whole spool, but I just want to show you how this thing works, go over it, talk about it a little bit, see what you guys think. If it's something you're interested in, it's coming right up. So here we have the spool rewinder. It's not for winding filament if you're extruding, making your own. This is for transfer of filament from spool to spool. I don't use it that much, but when I do, I'm glad I have it. That's why I made it. It's a pretty simple design. Some things were designed by me, such as these the brackets here, the motor mount, and a lot of the other parts excuse me, were pulled off of Thingiverse. This spool actually right here has to be a driven spool, and this was originally designed for 608 bearings on all of these. So I had to go into the best program I found for modifying steels with no so-called BS is Tinkercad or Tinkercad. It is made by Autodesk, believe it or not, but it is an online application just like Fusion 360. But if you import a steel in the Fusion 360, it comes up not smooth. It's a bunch of triangles, and it's hard to manipulate that. So if you're looking to change STL files and modify them, then I suggest that you try Tinkercad. So I'm holding this phone right now. I did buy a tripod. I'm trying to get non-ghetto, but it's going to be kind of hard for me to show this without with that being on a tripod. So bear with me. So I did design this or make it with a thought in mind. I wanted it to fold up so I could put it underneath the bed or in the closet without the stanchions or these sections being raised. Makes for kind of a flat pack. So basically what this does, and I'll try to one hand this here, but you just loosen these up and just loosen bring that in, and it locks down in the position, and then you just tighten that nut up. It's the same thing with this side. Just locks in the position like that. You don't have to muscle it down, just tighten it up just like that. And then you have your free side here, and you have your driven side over here, and this is the pulley that I had to modify the back side so it would accept a nut, because it was supposed to free will like these. And like I said, Tinkercad's where I did that. The pulleys, I did a little bit of calculations here, and I believe this runs at about 500 RPM. Or for this this motor here. I originally had one from like a vacuum cleaner, you know, a handheld, but it's more for speed than torque. So I bought this one. It's a different part number and it has a higher torque and a lower RPM. But anyway, this is I believe a 22 tooth, and this is, I want to say 180 or something like that. I don't remember the exact number on it. I'll post it in the description on Thingiverse. You can look at that pulley. So this, again, we got playing again with the flash going off on me, but I hope you guys can see this. This is the controller. It's a DC 12 volt controller, speed controller. It's a kit that I built, I believe it was a Filament kit years ago, and worked out that I could use it. So it actually came with the case on the bottom, so I just designed out and 3D printed this top here. And then this is a 12 volt power supply, which this controls. It's on and off, lit switch, a little bling, I guess. And then you have a variable speed right here, so you can pretty much go from 0 to 500. I found 500 on here is real fast. So I'd like to design a brake for this. We'll come up with something. I have an idea, but as it goes right now, you have to kind of keep a check on this spool here so it doesn't get going too fast. If you have to stop or you think you screwed something up and you just shut this off, the momentum will keep this going in a long line, and it makes a mess on you. So out of this whole thing, that's the downfall of it, and I got to come up with something for that. Put some kind of brake on it. So I'm gonna flip this around and show you the other side. Not a big deal over here. That's just the motor there. See if I can get a little light on that, but you can see that's the mount I designed. Get that in the focus there. So the motor is like pinched in there, and also this slides up and down so you can tension this belt. Just the wiring coming out, and I have it plugged in to the controller there rather than like a hard wire, so you can unplug it. Probably not a big deal, but I kind of like that, so that's why I did it. This connector box here for the IEC, again, it's off of Thingiverse. I didn't design that. I just printed it up. I thought it was a good design. Took quite a while to do it, but so this has a breaker in it and accepts your typical computer cord. I don't know if you can catch that. Sorry about the lighting. Like I say, I guess I'm a little ghetto here, but doing the best I can right now. So that's how that looks on this side. So this is just a bolt in here, and then on this side I had some extra pillow blocks for the another set of lead screws that I had for the 3D printer. I mean, you can order these on eBay. They're like next to nothing, probably for $5 or $6. So I went ahead and used those. Go ahead and turn it around. So again, on this side, this 22 This is the smallest metal pulley that I could find, and I actually had to order that thing from China, man. It has a set screw in it. There were some on Thingiverse that you could print, but this actually fit. I believe it's a 2.5 millimeter or something like that shaft on this motor with the set screw, and you know, that was absolutely perfect. So it actually didn't take that long to get here. I'm surprised. So I went ahead and ordered that. I'll look up the size of this belt. I can't remember. I ordered a couple of them, and they were all too small, so I had to order something in between. I couldn't find anything any different, because I did want to move this up a little bit closer, but if you wanted to change your gear ratios in here, like I said, this is adjustable up and down. I don't see a reason to do it, but you know, some people might if you were to make something like this, but it all worked out good. This is just L channel from Home Depot. 1 inch, I believe, by 1 inch by like an 1/8 inch thick. You don't want anything, you don't want the thin stuff, so you're gonna have to step it up with that. It's not very expensive. It's like $12 for like 4 feet of it. I just sanded that and painted it black. On the brackets for the pillow block, there's a lot of extra left over, so that's how I made the mounts for that. And they're just sandwiched on here. Hope you can catch that in there. Again, sorry about the lighting there, but it is what it is. Maybe you can see a little bit better from this side if I can get this light down here. Yeah. I think you know what I'm talking about. So one side, on this side, these screws go through, and then they're tapped on the other plate. Just made for a little bit of a cleaner install. You can probably, let's see if you can catch those in there. There you go. You can see that. So they're tapped on this plate. So overall, I think it came out pretty good looking. So what I'm gonna do is I'm gonna throw some spools on here. Get them pre-wound. So all you're gonna do is just put a spool on here. Or you know what? Maybe I'll just show you. I'll go ahead and take these off. Like I said, maybe I'm gonna try to set this up on the tripod. But my voice may go in or out, maybe a little bit lower, and that's kind of not what I want to do. So we'll go ahead and get this set up, and I'll bring you back. All right, so since I don't have a headset here, you'll see me walking around. I got to come back and talk on this. I put this on the tripod, so I'll go ahead and load the spools up so you can see how it's done. It's pretty straightforward and simple. And then we'll come back and look at it. So this spool right here that I'm loading, I'm going to put on the back. I'm going to wind it on to this bigger one. I actually do want to do a full spool of something else because my box is like full. I have like 30 rolls of a freaking filament now. So some of them are like this, some are like this, and I want them all this size. They take up less space, and they fit on my machine the way I want them to, the way I design the mount. So let me go ahead and throw these on. Hope I don't get in the way here. I'll try to stand off to the side. So if you can hear me talking, that's great. I'll raise my voice a bit. I'm a former Marine, so you know, we all like to talk loud. So that's all you gotta do. This one has a little bit of tension on this nut right here. I gotta put that. Originally I was trying to put a brake on here. Other than that, it would just spin down, but it didn't work out. The spring was winding. So the only thing that I can see, I could probably cut this bolt down slightly, but when I put a wider spool on this back side, it comes out to about right here. So I gotta be careful on how much I cut off. So run that down there. See, that spins nice and good with those bearings on there. You just take this side, put it over here. And by the way, these cones fit pretty much any spool, but you can see how that one spins down. That's why I like the other side, but until I find a brake or something like that. But you can see how this is driven now. This actually drives the motor, whereas this side freewheels. So all you do is just take your filament. Same thing as if you were using a drill. That's your bag. You know, you can do that. But let me get a piece of tape here, and then what you want to do is tape this into a corner to start this. So let me tape that down, and then we'll come back. All right, we're back here. Let me caution you, when you take this filament and put it to the other spool, make sure it's not twisted. Like, twist it on there, make sure it's following the curve of the way it was wound on this spool, because if you don't, you're going to have an unwinding issue when you put it on the printer as the extruder is pulling it through. So keep that in mind. So you can see how the curve of this goes up and over. So all you're going to do is just start it a couple times like that. Now you can't see that in there. This doesn't have to be perfect. This isn't going to auto wind on here like a fishing reel. But you want the goal is to transfer this as tight as you can over to this side. So what I do, let's see if I can swing that up slightly, is I'll kind of put my arm on this side of the spool and hold it so I can control it. And then I'll just use this hand and move from left to right. And, you know, this is pretty thick, so it's going to want to jump over and not wind perfect. But just roll with it. Just trust me, just go with it. The goal is not to cross the filament over, but you want this to be able to flow. So what I'm going to do is control it with this. And we'll just mainly see if I can move this out a little bit more so you can see how I'm doing this. Put that about right there, and hopefully, let's see, I don't think I'm going to be in the way, and we're going to get going. I'm not going to open this up wide open. There's not a reason to do that. You're going to get in trouble, especially without a brake on this reel. So let's go ahead and wind this up. I'll make sure I got all the slack out of there. Just turn that on and get going. You can see I have my arm on this other spool. I'm just going left to right. Keep an eye on your spool that that you're winding off of. You don't want this to jump out of your hand. So I'm going to turn that off because I can't see it right now because I'm trying to do this video. But I got a little bit more to go here. I'll keep an eye on it from the back side. Okay, I'm coming up on the end. There we go. There it is. There's the end of it. You saw how I controlled this spool with my arm. It'll probably burn your arm. That's why I got a sweatshirt on so it doesn't burn my arm. That's why I want to break from this side. But this thing works super, super good. I'm telling you. And I'll show you the results here. Well, that broke on me. I'm going to go ahead and thread that in there like that. We'll pull you off the tripod here so you can see. You can look at that filament in there. It would have been more perfect than that, but you know, I was trying to show you guys this video, but in a nutshell, that's how this thing works. I can't complain. So I was able to get the flash back on, but you can see that in there. It's as good as you get at a factory. You can wind the whole spool here. It'll take you less than a minute. I mean, you know, there's guys that use drills or whatever, but I wanted to make this. I had this idea and thought in my mind. It works excellent. Works for me. It does exactly what it's supposed to do. And by the way, this is a 3/4 melamine. I just edged it out. Put the iron-on edging on there, but 3/4 melamine is some scrap stuff I had from the CNC router. So that about does it. I'll post some links to the pulleys if anybody's interested in that. Pretty simple design. It did take some thinking. It did, especially for these stanchions, because they don't just slide on. They don't slide up and down. They have to be slotted. So they slide that way and then in to lock them in. So these are actually locked in here even without this nut being tightened down. But that's it. I hope you guys like this. Let me know what you think of it. Anybody has any ideas for this break back here, that would be excellent. What I need is a square spring on here and a square bolt so the spring can't rotate. And then I'll put some friction washers. I'm pretty sure that's what I need to do, but it's hard to find a square spring. So anybody has any ideas other than that, let me know, and I would greatly appreciate it. And I'll do an update on this and show everybody that's. If anybody's interested in the STL files for these brackets that I designed, the motor mount, I'll post links to the motor mount if anybody's interested in that, or not the mount, but the actual motor itself, and also the pulley. And I'll find the length of that belt. I'm not sure if anybody really wants to build this thing, but at least this will give you some ideas. So once again, please like, comment, subscribe. You got any questions? I'll answer those as best I can. You may find yourself looking at something like this, maybe on a different design. This was actually pretty easy. Well, I don't want to say easy. It took a lot of thought, but now in hindsight, it's easy. So, thanks for watching.